In this lesson, we are going to solve a question from exercise 4.3 of Maths and Stats Commerce Stream Part 1 book. Uh, this question is related to finding out for what units the profit can be maximum. Now, you see, this is a application of derivative. Let's take a look at the question. The total cost of producing X units is rupees x square plus 60x plus 50, and the price is rupees 180 minus x per unit. For what units is the profit maximum? So this is what we need to figure out. For what number of units we can have the profits maximum. There's something which you need to pay attention in this question is that the total cost of producing X unit is given to you, and the price is rupees 180 minus X per unit. You see, this price is selling price. Well, the question should have specified it, but anyways, you need to decipher here appropriately. This price is the selling price per unit. Let's take a look at the solution. So, take a look at the solution. We have been given that total cost of producing X units is rupees x square plus 60x plus 50. Giving this function a name as Cx because it's a equation in X. So let's call this cost function as Cx. It is rupees x square plus 60x plus 50. Selling price per unit is given as rupees 180 minus X. Now this is what is given in the question just as price per unit. It is selling price per unit. So we know that total sales is equal to number of units sold into selling price per unit. So basically total sales is number of units sold into SP per unit. We know the number of units sold is X and it's multiplied by SP per unit, which is 180 minus X. So total sales eventually what you get is rupees 180X minus X square. We have opened the bracket out here. We say 180 minus X square. Now we also know that profit is equal to total sales minus total cost. So profit is equal to 180 minus x square. Let's put it into bracket because as a part of good practice, whenever there is an algebraic expression more than one term, let's club it to into a bracket, and then in the subsequent step we open the bracket. It gives you better value, effective value. Total cost is minus x square plus 60x plus 50. So profit, when we remove the brackets, we get 180 minus x square minus 60x minus 50. And I hope you understand this negative sign is creating a change in the terms inside the bracket when we open the bracket. When we collect it, we get profit as 120x minus 2x square minus 50. Rearranging, let's call this function as fx. Let's call this profit as fx. It is basically a function of x where we get 120 minus 2x square minus 50. The question has asked us to maximize the profit. So basically, what it implies is that the function fx needs to be maximized. So it's a question of maxima. We need to find out for what units the function fx is going to be maximum. So we have got fx is equal to minus 2x square plus 120x minus 50, and our job is to figure out the maximum value of fx for what value of x this profit fx is going to be maximum. Differentiating both the sides with respect to x, we get f dash x is equal to minus 4x plus 120. And to get extreme values of x, let's equate f dash x to 0, which is basically minus 4x plus 120 is equal to 0. So we get minus 4x is equal to minus 120, which is x is equal to 30. And now let us have a second differentiation. So again, differentiating f dash x with respect to x, we get f double dash x is equal to minus 4. So for x is equal to 30, we get f double dash is equal to f double dash 30 is equal to minus 4. And basically it means f double dash 30 is smaller than 0, and we know the condition that the function will be maximum if f double dash x is smaller than 0. So this implies fx has maxima for x is equal to 30. So profit is maximum for x is equal to 30 units. So that's our final answer. Thank you very much for watching the video.